The -1, 1 range is easier for the network to deal with because it's smaller and centered at 0. Another trick is that I'm not using a ReLU as my activation function, but rather something called a leaky ReLU. A leaky ReLU can output negative values while still being nonlinear, and has been shown to generally improve performance. So I'm using a leaky ReLU in all of my layers except for the last one. Except there is a different squishing function called tanh that squishes its inputs between -1 and 1. I can then normalize those outputs into the final range of 0, 1. Intuitively, this is because tanh is centered at 0 and plays much nicer with backpropagation, but ultimately the reasoning doesn't matter as much as the results. Both networks here are theoretically universal function approximators, but practically one works much better than the other. This can be measured empirically by calculating and comparing the error rates of both networks. I think of this as the science of math, where we must test our idea